Hi, for this exercise on working with the MemDes design extension, we'll use the portal structure example. You can also access it here from the examples drop-down when you start up the software and select number 12, portal structure example. I'm going to switch off the analysis workflow for now because we would like to add a combination case to the existing two cases we've got here. We've got a LC1, which includes the own weight of the structure, so we can see it contains the self weight. And then we've got LC2 here, which is all of our live load components. And to demonstrate that, we can switch on the show loads. Of course, for the own weight, we don't see anything because it's contained within the structure. But if we switch our load case, our active load case to LC2, we can see we've got all those linear loads applied there. Great. One side note, if we wanted to use a second order analysis, all we need to do is to change the selected row analysis mode to nonlinear and the type static, and then we can choose second order and click apply, and that will adjust that load case to be second order. We can do the same for the second one, which is our live load, and it's as easy as that. Now if we jump to load combinations, you can see we've already got columns here for LC1 and LC2, and if we had more load cases, they would be displayed there. Let's add just one combination here, and for LC1, which is our own weight, we'll just add a factor of 1.4. So we'll just click on the plus button, and then for load case 2, we'll add a factor of 1.6, and we hit apply. And it's as simple as that. So we've got our loads and our combinations set up. Then we're going to right click and choose run analysis to run the analysis. So we've got 3 cases running, LC1, LC2, and the combination 1. Right. Once that is all finished, we can switch our current case, since we're in the results mode, to combination C1. Okay, and we can switch on our deflections, and we can see and verify graphically that we've got something happening in the model. And if we switch on the plot values, we can see our deflection values. Of course, we can do the same for axial forces, moments, and so on. All right, now that that's done, let's have a look at the plot functions. We can right click on any member in the model, choose select chain to select all connected elements that are aligned with that element, and we can click on the plot function. When we do that, we've got access to different outputs. So deflection X, Y, Z, we can look at the axial force, we can look at the shear Y, shear Z, torsion, moments Y, and moment Z. At any point, you can select the pick button and you can add additional elements to your selection. It doesn't have to be in any particular order. As long as they are connected, then the software will automatically arrange them, and when you click on update, it will plot those updates for you accordingly. So easy as that. Right, so that's how we plot graphs and outputs within GenFEA. Now if we wanted to send this to MemDes, we can follow the same principle. We do a select chain for an element. So this is a discretized element, but in reality that would be one continuous element from start to end. So once it's selected, we right click, we go to design group, go to SESOC, and choose MemDes. By the way, if you don't see the MemDes option there, you can enable it from the application settings. So you'll see that there's an enable SESOC design exports button here, and when that is switched on, you will see the MemDes option appear down here. Now by default, it will select the moment ZZ as the output criteria, and you'll see that this looks very similar to the plot outputs we had before, with a slight variation. In this version, it will actually split up the segment, so we can see the green dot represents the end of a span point within the selected group of elements, and the red dots here are the segments where we've got the points of contraflexure, since we are selecting the moment ZZ. If we select a deflection, then that will simply be a crossing point that we see there on the screen. So if we go back to moment ZZ, we can see we've got one segment up to here, then we've got another segment spanning to there, and the final segment at the end. So we select the desired segment. In this case, we leave it as segment 1, and if we want to, we can look at the properties that it will be sending to MemDes. These values will be pre-populated from information from the model and the selected segment. If we look at the major bending here, for example, is 10.5, And if we change this to segment 2, then we expect that to change, and we can see that's now 5.2, reflecting the values that we've got here on the screen. We'll go back to 1, and we'll leave all of the values as default, and we'll just click on export. So when we do that, it's going to export the MemDes file for us. And if you've got MemDes installed, all you need to do is double click on it to open. So we'll give that a second to open. And we can see now we've got our member exported to MemDes. It's already brought across the section properties. It's populated the flex shear, axial, and if we provided it, and in this case we didn't, but if we did, the fire and advanced criteria. And from here, we can simply click on calculate, and we can look at the calculation results. So there we go, from analysis results in GenFEA through to MemDes with calculation outputs. So as simple as that. Thank you. See you soon. Bye.